So hello everyone again, and Bismillah. So in this video, I'm going to show you some of the experiments that were conducted in the paper. This video will be an overview of the experiments. If you want to have a detailed look at the experiments, you may have a look at the paper itself. It has the full tables, it has the full comparisons with the state-of-the-art algorithms. So let's go. Now, first of all, I'm showing you the process of generating equally spaced nodes. We start by huge spacing between the nodes, in which we will have a sparse spreading of the nodes in the map itself. Now we have to notice that this is the exact sample map we need for our algorithm to run on. So it's a map consisting of white areas and black areas, in which white areas represent the traversable areas, while black areas represent obstacles. You can see that the nodes were generated over the white areas. The nodes that were overlapping with the obstacles have been gotten rid of from this image and other images as well. You can see then that when we reduce the amount of spacing between the nodes, the image gets crowded and crowded again, in which we can reach a level that in which the image itself seems to be red, although it's white, but because of the crowdedness of the nodes, of the generated nodes, it seems to be a red image. However, there is a trade-off between between the amount of generated nodes and the complexity, the computational complexity of the algorithm. This trade-off is present in this table. We can see that, a quick overview, when the spacing was large, we have a less number of generated nodes. However, when the spacing was, small, we have a huge number of generated nodes. And you can see, the most time-consuming process is the neighboring graph generation process, because it relates every single node to its neighbors. We know that every node has 8 neighbors. So, when you add a node, you are adding at least 8 calculations to your task. So you can see that when the number of generated nodes was 2,176 nodes, we have less than 1 second to generate the graph, while when the number was 33,252 nodes, we have had waited for almost 17 seconds to generate the neighboring graph. This is a huge difference. So you have to pay attention when you specify your spacing, because if you do not have to set your spacing to be very small, set it as large as possible. This will help you reduce the computational complexity of the algorithm, and it also helps you make your path, or the path of the robot, smoother actually when the spacing is large. Now, in this experiment as well, we have 2 types. At the first image, in here, you can see that the starting node, the node colored with purple, is isolated from the goal nodes. The goal nodes are the green nodes. In this image, we have 100 goal nodes. This is a huge number of goal nodes that are to be visited. But the thing to notice is that the starting node is isolated from them. We have constructed, we have ordered the goal nodes, then constructed a closed path. And we mean by closed path, we mean that the robot starts from the starting node, it goes to visit all of the goal nodes, and then goes back to its starting position. We have also constructed an open path in which the robot starts from the starting node but does not go back to it. In the second scenario, we have also 100 goal nodes to visit. However, our starting node is located in between the goal nodes themselves. It's not isolated. You can see it in here. It's in between. The goal nodes are surrounding the starting node from all directions. Unlike this scenario, we do the same thing. Actually, we order the goal nodes. We present you an example of closed path, then an example of open path. Now you may say, what's the difference? Actually, we have presented 2 methods. The MuGONA itself, the main algorithm, works in the first scenario when the starting node is isolated from the goal nodes. However, when the starting node is located in between the goal nodes, it's an unisolated starting node. We presented the shell layers algorithm. If you want to look at these scenarios in more details, you may have a look at the paper, and I will be attaching or inserting the link of the paper into the description, inshallah. In here, we have a very brief table that shows us the quantitative features of doing the processes needed to order the goal nodes. So, for example, for 100 goal nodes, the algorithm took almost 106 seconds when the path was closed, but for the isolated one. Yeah, and for the non-isolated one, it took less time. This is maybe because shell has less computation complexity. All the details are actually in the paper, as I mentioned before. You may also have a look at the costs of the ordering processes. It's remarkable that when you have a closed path, you have more cost. However, when you have an open path, you will have less cost. This is very, intuitive, because in the closed path, we have to go back to our initial starting node. So in this experiment as well, we have shown that if you do not smooth your path, you will have those kinds of abrupt changes in the path. These sharp angles will cause your robot to face some difficulties in control, difficulties in changing its direction. So the B-splines smoothing technique, it smooths the path. It tries to make it more appropriate for mobile robot navigation. We also conducted some experiments on some publicly available datasets. You can have a look at these. These are from some games that were available online. Some of them are from some GitHub repositories. You can have a look at them from the paper itself. We were successfully able to generate our paths. We were successfully able to generate the equally spaced nodes. We were successfully able to smooth the paths after generating them. As long as the provided maps satisfy our conditions, they are pre-processed as we want, our algorithm will inshallah be able to perform its tasks. And you may see that in this certain algorithm, in this certain image, the available areas are not exactly white. They are rather maybe gray, but as long as they are not black, they are not very close to be black, everything will work in a good way. Now we will be also showing you some real scenarios in the upcoming videos. How are we going to run this algorithm in a code environment in VS Code, inshallah.